Have you ever wondered if humans could travel to the sun? This celestial body has captivated our imagination since the dawn of civilization. From ancient sun deities to modern solar panels, the sun has always been a pivotal cornerstone in human culture. The sun, a blazing sphere of plasma, lies at the heart of our solar system, influencing every aspect of our existence. It's the ultimate frontier, one that seems nearly impossible to reach, yet it beckons the bold and the curious. Historically, the journey to understand the sun has propelled numerous scientific endeavors. Take the Parker Solar Probe, launched in 2018. This mission marked a significant leap, venturing closer to the sun's surface than any spacecraft before it, enduring unimaginable heat and radiation to gather vital data. This mission, among others, represents the pinnacle of our current technological capabilities in solar exploration. So, what would it actually take for humans to embark on a journey to our closest star? First, let's understand our target, the sun. A colossal sphere of blazing energy, the sun sits at the heart of our solar system, a mere 93 million miles from Earth. This star, composed primarily of hydrogen and helium, fuels the vast nuclear furnace that powers its radiant glow. Imagine a ball so vast that about 1 million Earths could fit inside it. That's the scale of the sun. Its immense gravity holds the solar system together, orchestrating the ballet of planets, asteroids, and comets that dance around it. The sun's light and warmth are indispensable to life as we know it. Photosynthesis in plants, which supports almost all life on Earth, relies fundamentally on solar energy. Moreover, the sun drives our weather systems and influences climate patterns, making it a pivotal force on our planet. With such extreme conditions, the challenges of solar travel are immense. Imagine facing temperatures around 5,500 degrees Celsius. That's the reality of the sun's surface. Now, as we ponder the possibility of journeying closer to the sun, we must confront the formidable heat barrier that stands in our way. The heat and radiation near the sun are not just extreme, they're almost beyond current technological comprehension. To put this in perspective, the melting point of steel, a material we often think of as very durable, is around 1,500 degrees Celsius. The surface of the sun at 5,500 degrees could vaporize it in mere moments. This immense heat, coupled with intense solar radiation, creates an environment that is incredibly hostile to any form of traditional spacecraft. Enter the marvels of modern science, materials and technologies that can withstand these extreme conditions. Take, for instance, the Parker Solar Probe, which NASA launched in 2018. This probe utilizes a revolutionary heat shield known as the thermal protection system. It's designed to withstand temperatures up to 1,370 degrees Celsius and protects the probe's instruments from the sun's fierce radiation. This heat shield is made from carbon composite materials, which not only resist high temperatures, but also protect the probe from being obliterated by high-energy particles from the sun. Such materials are at the forefront of our quest to understand more about our closest star and potentially travel closer than ever before. But heat isn't the only obstacle on this fiery path. Radiation levels near the sun are lethal without unprecedented protection. When considering a journey to the sun, one of the most formidable challenges is the intense solar radiation. This radiation, primarily composed of high-energy photons and charged particles, can wreak havoc on spacecraft electronics and pose severe health risks to astronauts. Solar radiation includes X-rays and gamma rays, which can penetrate the shielding of most modern spacecraft. This not only risks damaging the sensitive electronics aboard, but also increases the risk of cancer and other health issues for any human on board by directly damaging DNA. Imagine the complexity of designing a shield robust enough to protect against such relentless bombardment. Now let's shift gears and talk about the speed needed to reach the sun. To make the journey in a reasonable time frame, a spacecraft would need to travel at unprecedented speeds. Currently, the fastest man-made object, the Parker Solar Probe, travels at about 430,000 miles per hour. Yet even at this staggering speed, a direct journey to the sun would take several months. Achieving and sustaining such high velocities presents its own set of challenges, including immense energy requirements and the need for advanced propulsion technologies. The thermal stress alone from high-speed travel through varying intensities of solar radiation would require materials and engineering solutions that are currently beyond our grasp. Overcoming these barriers requires innovations that push the boundaries of current science. What futuristic technologies could possibly make a sun journey feasible? As we gaze toward the fiery heart of our solar system, the prospect of venturing close to the sun hinges on breakthroughs in several advanced fields. Firstly, consider propulsion technologies. Traditional chemical rockets lack the efficiency for such a formidable journey. Instead, the future may rely on nuclear or ion propulsion systems. Nuclear propulsion, leveraging the energy released by nuclear reactions, offers vastly more thrust and efficiency compared to conventional methods. On the other hand, ion propulsion, which uses beams of ions for thrust, presents a method that, while producing less immediate power, offers a far longer operational lifespan, ideal for prolonged deep space missions. Moving beyond propulsion, the survival of a spacecraft in such extreme conditions as those found near the Sun is contingent upon advances in material science. Imagine materials capable of withstanding incredible temperatures and radiation levels, materials not yet invented but which could one day line the hulls of sunbound spacecraft. These materials would need to be not just resilient but also highly adaptive, capable of self-repair, a feature straight out of the annals of science fiction. And then there's the theoretical marvel known as the Dyson sphere. This colossal structure, a concept proposed by physicist Freeman Dyson, is envisioned to encompass a star entirely, capturing most or all of its energy output. If humanity were ever to construct such a megastructure, it would not only signify monumental advances in engineering and materials, but also place us at the doorstep of becoming a Type II civilization on the Kardashev scale, capable of harnessing the energy of an entire star. Such technologies, while sounding fantastical today, are underpinned by real, ongoing scientific inquiry. The line between what is currently science fiction and what is scientifically feasible is continually being redrawn by our relentless pursuit of knowledge and innovation. While these technologies sound like science fiction, they may hold the key to solar travel. With these immense challenges, what do scientists currently say about a manned mission to the Sun? At present, the consensus among the scientific community is quite clear. A manned mission to the Sun is not feasible with our current technology and understanding. The extreme conditions near the Sun, including unimaginable heat and deadly radiation levels, create an environment that is far beyond the limits of human survivability or current spacecraft technology. However, this has not dampened our curiosity or halted our pursuit of solar knowledge. Instead, the focus has shifted towards more sophisticated and capable unmanned missions. For instance, the Parker Solar Probe, launched by NASA, is an excellent example of current endeavors to study the Sun. This probe is designed to get closer to the Sun than any previous spacecraft, facing brutal heat and radiation to gather valuable data that could not be collected from Earth. These unmanned missions are critical, as they allow scientists to test theories and collect data about the Sun's composition, its atmosphere, the solar winds, and magnetic fields. Each of these elements plays a crucial role in understanding not just the Sun, but also the broader workings of our solar system. The insights gained from these missions are vital. They help improve our ability to forecast space weather events that can affect satellite operations and communication systems on Earth. For now, our journey to the Sun remains within the realm of robots and remote sensors. So, will there ever be a trip to the Sun? As we've journeyed through the complexities and challenges of approaching our blazing star, it's clear that a trip to the Sun is fraught with formidable barriers. The scorching heat and intense radiation alone make it an endeavor that stretches the limits of our current technology and understanding. We've discussed the staggering temperatures that any spacecraft would need to endure, temperatures that can climb into the millions of degrees Celsius near the Sun. The Parker Solar Probe, which ventured closer to the Sun than any previous mission, has given us invaluable insights. Yet it remains a safe distance away, shielded by cutting-edge heat-resistant technologies. Radiation presents another significant hurdle. The Sun emits powerful solar radiation that could cripple conventional spacecraft electronics and pose severe risks to human health. Speed, too, is a factor. Reaching the Sun requires navigating the immense gravitational pull of our star, a feat that demands unprecedented propulsion technologies. However, the future holds promise. Advances in materials, science, propulsion systems, and autonomous technologies are continually being developed. These innovations might one day allow us to send more sophisticated probes or even manned missions closer to the Sun than ever before. The spirit of human curiosity and ambition has always pushed the boundaries of what's possible. From the first moon landing to the Mars rovers, each step in space exploration has paved the way for the next. Though a manned mission to the sun isn't on the horizon, the spirit of exploration continues to ignite our drive towards these celestial quests.